Hello everyone, we come back for this week's lecture. In this week, we will talk about data visualization. Same as last lecture, Professor Chi Liu will be presenting for the majority part of this lecture, using both R and Tableau. I will be making some extensions after her lecture.
Hello everyone, welcome back to the Audit Analytic course in this week. Let's start to discuss some data visualization techniques. In our last week's lecture, we discussed the descriptive statistics, which could reflect the nature and patterns that are inside the data. While most of these descriptive statistics we discussed last week are presented in numbers, for the data analysts, they can fully understand data according to these numbers. While for the other kind of people, like the managers or the stakeholders or the investors, these numbers maybe doesn't make any sense for. So in order to let these people gain as much information as the data analysts, we'd better to find another techniques to present data in a more intuitive way and make this presentation easier to understand. This is data visualization techniques that we are going to discuss today. So first, what is data visualization? Data visualization is the graphical presentation of data that lets the user see the data in order to help them better understand information. So it's not just the table or just the numbers, it's a graphical presentation of data. This graphical presentation may entail manipulation of graphical entities and attributes. For example, in the data visualization graphs, we can include points or lines or shapes or images or text in this graph. And also, we can add the color, size, position, and shape to show more information. With data visualization, patterns, trends, and correlations that might go undetected in text-based data can be exposed and recognized easier. This figure, created by David McCandless, shows the components of a good data visualization. So the four components of data visualization are interestedness, function, form, and integrity. The interestingness means that you should make sure that your audience care about what you want to say. The data you presented should be relevant, meaningful, and new. And integrity means that what you say should be truth, consistent, and honest, and accurate. While form means that you should say things in a nice-to-hear way, which should be beautiful, structured, and appearance. While function means that you should be able to make sure what you said is easy to understand. A good data visualization should include all these four elements. For example, if you only have the interestingness, the function, and the integrity without form, your data presentation will be ugly. While if you only include the interestingness, integrity, form without function, your data visualization will be useless. If you only have the integrity, the form, the function without interestingness, it will be very boring. Finally, if you have the interestingness, function, form without integrity, it will be rubbish. So after you make a data visualization graphs or charts, Please check that whether you have all these 4 elements. Okay, so first, let's go through some basic data presentations. Just a little bit review about the variable types we have discussed last week. We can generally group the variables into 2 types, the qualitative variable and the quantitative variable. While in the qualitative variable, we can have nominal variable and ordinal variable. So as you have known that there are some descriptive statistics that are specifically for the qualitative data, whilst the other descriptive statistics can be used for the quantitative data. The data presentations are the same. We can see from this table that for the nominal data, we can usually use a pie chart, the column chart, or bar chart to present them. While we can also use linear chart or Ogives chart to present the ordinal data. While for the continuous or the quantitative data, we usually use histogram, frequency polygon, Ogives, scatter plot, box plot, stem and leaf plot. Okay, now I'm going to discuss these basic data presentations or these charts one by one to show you how this graphs or these charts looks like. Okay. The data we're going to use in the demonstration is still the employee master data that we used in the last week's lecture. Okay. The first chart we're going to discuss here is the pie chart. A pie chart is a circle divided into sections with areas proportional to the frequencies or the relative frequencies of the categories of a variable. You can see that this is a pie chart that's showing the relative frequencies of the work department variable. And now I'm going to show you how to use R to make this pie chart. First, let's open R, go to Start, R. Okay, then we add a new script and show them vertically. Okay, now before we can start the analysis, first we have to import data. As we did last week, first we assign a name to the data. It's employee master. Then we use the read table command. Okay. C. In the C disk, it's a delimited file and the separator is tab. And the header is true. Then let's see, have we imported data successfully by run this code? Okay, now we can see the data here. Yes, we have already imported the data now. Okay, then we have to choose the column here. The work department column. Okay, so it's just a little bit like the review of what we did in last week. We still first assign a name to the column, this work department, and we first referred table is imp master, and use a dollar sign to connect the table and the column name. It's work department. Okay. Now still because we want to show the frequency in the pie chart. So we first calculate the frequency of this column. Use table comment of work department. This column. Then another comment that led us to present the data in pie chart is called pie. So we just type pie and want to present the frequency of this data. Okay, now we just run this script. Okay, here comes the pie chart. So this is a very basic pie chart to present the frequency distribution of work department column. Okay, if you want to see what else we can do with this pie chart, you can just type help and to see which parameters that we can use in this command pie. Okay, then we run this script. It will bring you to a web page that shows all the parameters you can use for this command pie. For example, one parameter here is called COL, the col, which means that we can assign different colors to different slices of this pie chart. For example, in our pie chart, we have 8 slices. Then we could use this parameter to add different colors for each slice. Like for example, we use this by work department frequency. Then we use CL. Because we have 8 different colors want to assign to this parameter here. So first we assign these colors to a vector using a command called C. Okay, the first one we're going to assign is red, then orange, then yellow, then blue, then green, then purple, black, and then pink. Okay, now let's see the change of this chart. We run this, you'll see that. So in each slice of this pie chart, it have different colors that you gave. And here are some other different parameters for this pie chart command. So you could try to explore different parameters here by yourself. Okay. Now then, after the pie chart, we go to the second type of chart. It's called a column chart. The columns in the column chart are constructed to show the frequency or relative frequency for each category. So usually the columns are equal in width And it is important that the vertical scale starts at 0. Otherwise, the heights of the columns are not proportional to the frequencies. So this picture still shows the frequency distribution of the work department by using the column chart. And now I'm going to show you how to create this column chart in R. Okay, then let's open R. The command in R for the column chart called the bar plot. And then we first need to refer the data we want to present as work department frequency, and then we set the color to all the columns, like we set it pink, and then we could define the name of the axis we call it as work department, and then for the y-axis we call them number of employees. So you can see that here we use X lab and Y lab to assign the name for the x-axis and y-axis. Then we can set a limitation of the range that appears in the y-axis. We use y limit equals to a vector from 0 to 12, because we know that the largest frequency in each department is below 12, so we assign the 0 and 12, and then we run the scripts. It shows the bar chart of the frequency distribution of the work department. Okay, and then the next chart is still the column chart, but we can include another attribute in this column chart by adding colors to each of the columns. For example, in this column chart, we add gender information, like to show how many employees in different genders in each work department. Okay, so the data we are used in this demonstration include the sex column and the work department column. Okay, now I'm going to show you how to use this in the R. First, we need to make a frequency table that including the gender information. So let's define this as the multi frequency, and we still use the table function to create this frequency table, but include the gender information. So here we need to add two variables in this function. First one is gender, so we use the employee master, and we refer to the sex column, and then also we want to include is work department. Okay, so first let's take a look of the frequency table first. Run this. You can see that here is the frequency table. So we know that for each department, there are how many females and how many males. Okay. Now we just need to use the bar charts to plot this table. Still the bar plot function. The data we want to display is multi-frequency. And in this plot, we want to add a legend to indicate which color indicates the female and which color indicates the male. So we just use a parameter called legend, and we try to make it, and we make it equals to 2, means that we want to add the legend to the chart. And also the color we want to assign is red and green. And still we need to add the name for the x-axis and y-axis. Using the x label and y label variable. The y limit also. Okay, then let's run this script. Here it shows the result. It shows the number of male employees and female employees in each work department. So after this, next we're going to talk about the bar chart. Actually, the bar chart is exactly the column chart, but the bars are horizontal rather than vertical. Still, they are constructed to show the frequency or relative frequency for each category. So usually the bars are equal in width, and it's important that the horizontal scale starts at 0, otherwise the length of the bars are not proportional to the frequencies. And also this bar chart still shows distribution of employees in each work department. So I'm going to use different charts to give you a vision of the same data. So in R, bar chart and the column chart have the same comment. They are bar plot. So the only difference is that the vertical bars change to horizontal. So we can copy this script, choose copy, and then paste it here. And we just need to make a little bit modification to make the column chart to bar chart. So we don't need to change the data, but here we need to add parameter here that called horizontal. That horizon equals to 2. To make the bars displayed horizontally, and then we need to change the name of the x-axis to the y-axis. And make the name of the y-axis to the x-axis. And the limit of y to the x. Then that's it. Then let's run this script. You got this bar chart. Okay. The same as column chart. In the bar chart, you can also add different colors to each bar to add an additional information. Here, like still the sex information. Okay, so very similar. When we go to R, we just need to copy this script that we made for the multiple column chart, and then add horizontal equals to 2. Change the name of x-axis and y-axis. And change the limitation of y-axis to the x-axis. Then we just run the scripts and got the results. So for now, we have introduced the 3 types of charts: the pie chart, the column chart, and the bar chart. All the 3 types of charts could be used for the nominal variable. While then the next type of chart, which is called linear chart, or so we can call it line chart, is designed for the ordinal variable. So the line chart represents the categories arranged in order. The frequency is represented by a dot, and then the dots are joined by lines to form this line chart. Since the work department is the nominal data, not ordinal data, so we cannot use it in the line chart. So we choose another column in the employee master data, which is called education level. Because the value of the educational level is ordered, so it complies with the definition of the ordinal data. So we choose this column here to demonstrate the line chart. Okay. Then I'm going to show you how to create a line chart in R. Then we go back to R, because now we have chosen another column. So we have to define this column first. Call it education level, which equals to employee master $. Let's go back to find the name of this. It's education level. Okay. First, we calculate the frequency of this column using the table function. And since the line chart can also use to display the relative frequency, let's try to do the relative frequency this time. Also to remind you how to calculate the relative frequency is we just use it definition using the frequency divided by the number of rows in the employee master data. And then the command used to create the line chart in R is called plot. So we use plot. Because education level is ordinal data, so we want to display the data according to its natural order. So first we have to sort the data to make it can be displayed in order. We use a function called sort to sort the data. And then first we need to find the unique numbers in the educational level. Use the unique function. Then we enter the data is educational level. And then according to this order that we sorted here, we want to display the data that relative frequency of education level. In the plot function, we could choose to display only the dot or the line, or both of them. Here we want to display both of them and to include both line and dot to our line chart. So here we use another parameter called type equals to b, which means both of the dot and the line. Then we set the color of the line and dot, which we will assign red, and again the name of the x-axis, education level, and the name of the y-axis, relative frequency. Okay, let's run this script. Here shows the result. You can see that we have both dot here and the lines to connect each dot in this figure. So this is the line chart that reflects the relative frequency distribution of educational level in the dataset. So a special type of line chart that's called Ogive is a graph of cumulative relative frequency of distribution. And then let's see how to create this figure in R. Okay, in order to display the cumulative relative frequency, first we need to calculate it. For the educational level, first we have to calculate the cumulative frequency using the function cumSum. Educational level frequency, and then use the definition using the cumulative frequency divided by the number of rows in the employee master data to get the cumulative relative frequency. And now, since this is the plot function is very similar as we used for the last plot, then we can just copy it and just need to change the data from the relative frequency to the cumulative relative frequency. And also we have to change the name of the y-axis to the cumulative relative frequency. Then let's see the result. Okay, here it shows the Ogives of the education level. Each dot here reflects the cumulative relative frequency for each education level. And then these dots are connected by lines to form this line chart. So for now, we have introduced the pie chart, the column chart, the bar chart, line chart, and the ogive. All these charts can be used for the qualitative data. Now we are going to see some figures that can only be used to present the quantitative data. Okay, the first one is a histogram. You can see that this slide shows a picture of a histogram. It looks very similar to the bar chart. While the class interval of histogram should cover the full range of data, and the bars are not separated from each other. So the area of each bar should be proportional to the frequency. Uneven class intervals are taken into account by the area of the bars. So since histogram can only be used for the quantitative data or the continuous variable, now here in this demonstration we use the pay per period, and we first group the pay per period into several classes that each class have a range of $500. Like we discussed last week, how to present the frequency of the quantitative data. Okay, then we just display this frequency into this histogram. So how to make a histogram in R? Let's take a look at it now. So still first we have to specify the columns we want to use. We define it as pay. It's employee master data. The column name of the data is pay per period. And in R, there is a function called histo that used specifically to create a histogram. First, we refer to the data we want to display. It's pay. Then we set the color to the histogram, still as pink. Then we name the x-axis as pay per period. Then set the limit of y-axis equals to from 0 to 20. And then we want to assign a label to each bars to show the number of the frequencies. So we use a parameter called labels, and make it 2. Then let's run this script to show the result. It's here. It shows histogram of pay per period. Okay, so you can see that each bar indicated that the number of employees that has the pay per period falls into each classes. And because we already used the labels equals to 2, so we have the numbers here for each bars indicating the frequency. Okay, then the other chart for the continuous variable is called the frequency polygon. The frequency polygon is constructed by joining the midpoints of the top of each bar. The frequency polygon is a chart that's based on the histogram, and it's constructed by joining the midpoints of the top of each bar. So you can see that this point is the midpoint of the first bar in the histogram that I have shown you in last slides. Then I find the midpoint of each bar in the histogram and connect them together to form this line chart, which is called a frequency polygon. And in R, in the package that comes with the R, there's not a specific function that can be used to create the frequency polygon. So we have to download another package. Then we choose the packages, and to install the packages, choose Miro to download it. It's the USA, the first Miro in the USA, and then find the packages in the list. It's called using R. Start with U. Here, using R, then choose it. It will download. And first, before we can use the functions in this package, we should to refer it using the function called library. So it's library. It's called using R. And then the function we want to use to create the frequency polygon is called simple dot frequency polygon, poly. So this is just like the histogram. We just first need to indicate the data, which is pay, and the color equals to pink. It's there, and the named axis, pay per period, and the limitation of y set it to 0 to 20. And then we want to display the labels. Okay, then we just run the scripts. It shows you the frequency polygon here. But as I said, that because it's based on the histogram, So it just to combine this frequency polygon and display it together with the histogram. So you can see that it's just to connect the midpoint of each histogram and to join them to form a line chart. It also shows the trend of the distribution of this continuous variable. Then the next graph is the scatter plot. A scatter plot is used to compare two continuous variables. So here you can see that the x-axis is one continuous variable. Here in the demonstration, we use the salary column. The y-axis is another continuous variable, which here in this demonstration is pay per period. And here the scatter plot is used to compare these two variables, salary and pay per period, to see their relationship. Well, you can see that there is a black line that goes through all these dots. Here, this line, we call it a trend line. By adding this trend line, we could show the relationship of these two variables and its direction. So this scatter plot shows that for most of the values in salary and pay per period column, there is a linear relationship. Why except this one, this dot has a very small variation. Why if there is a dot that exists here or here that very far from this trend line, then in an audit we may want to focus on this case to get further investigation. Now I'm going to show you how to create this scatter plot in R. Okay, here because we add another variable in our analysis, so still first we have to define it. We name it as salary and indicate it equals to the column named salary in employee master data. And then we use a function called plot to create the scatter plot. First, we define data, salary, and pay, these two variables we want to analyze. And we want to create them, give the color red to the dots in the scatter plot. And then we name the x-axis as salary and the y-axis as pay per period. Okay. Then we just run the script. Here is the scatter plot, shows the relationship of salary and pay per period, these two continuous variables. And then you can see that we don't have a trend line here in this scatter plot. If we want to add a trend line, we just need to use another function called add line. Here we create a linear regression model for the pay and salary using LM, this function. Then we set pay and salary. which will gives you the trend line. We'll run this. You can see that trend line is added to this scatter plot. As the same, just like the scatter plot I showed you, you can see that most of the dots are in this trend line, which forms a linear relationship of salary and paper period, except this one, this dot, there is a small variation. So we may need to investigate this dot. Okay, so for now, most of the plot or charts we have introduced can be created in R as well as in the other widely used tools in auditing, like the Excel. Now I'm going to introduce several other types of plots that cannot be made in Excel, but is also very useful to demonstrate the descriptive statistics. The first one I'm going to show you is the box plot. You can see that the box plot of a variable is a graphical representation based on its quartile, as well as its smallest and largest values. It attempts to provide a visual shape of the data distribution. This figure shows typical box plot and its component. You can see that the bottom and upper box shows the 25th and 75th percentile of the data distribution, while the band in the middle of the box shows the median of the data, while the whiskers that indicate the 1.5 times of this middle 50th percentage. While any data distributed inside the whiskers is considered the normal data points, while the data that's allocated outside this whiskers is considered to be the outliers. It has some different kinds of variations of the box plot. Sometimes the whiskers indicate the minimum and maximum of all the data, while it could also indicate one standard deviation above and below the mean of the data. Now, possibly it could indicate the 9th percentile and the 91st percentile, or the 2nd percentile and the 98th percentile. But anyway, the data point that inside this range is considered to be normal, while the data points are allocated outside the whiskers is considered to be the outliers. So let's take a look at an example of the box plot. Here I want to show you the box plot of the pay per period column. Let me show you how to make it in R. In R, there is a function called box plot. So we're going to use this function. And first we need to indicate the data is a pay per period. And we just need to add a title for this box plot. It's called box plot of pay per period. Then we run this command. Here shows the box plot of the pay per period data. We can see that actually this is not traditional box plot because the upper whisker and lower whisker is not equally in length. So it may indicate the 10th percentile and the 91st percentile of the data distribution. While this band here in the middle of the box shows the median of the data, and the top of the box shows the 75th percentile, and the bottom of the box shows the 25th percentile. Now we can see that there are 3 data points that are considered to be the outliers. So for the auditors, they may want to take a look at these 3 paper periods for further investigation. Okay, so this is box plot for a single variable. Now we can also display more than one variables in a box plot. Here shows the box plot of a qualitative variable and a continuous variable. It uses one box plot to show the distribution of the continuous variables in each category of the qualitative variable. So in R, we could still use this function box plot to make this. And now we need to indicate 2 variables. The first is pay per period, and the second one is education level. And we connect these 2 variables using tilde. And then we just need to assign a name to the x-axis. Name it education level. And also for the y-axis, pay per period, using the x label and y label parameter. Then let's take a look at it. Here is this box plot which shows pay per period for all the employees in each of the education level, which we can see that there were 2 outliers are shown here, and for the education level equals to 19 and 20, there is only 1 person here. So it cannot form a box, so it just a line here shows the median, actually the only one value. Okay. Actually, the box plot can also show the skewness of the data distribution. For example, the distribution of the pay per period in education level 15 is symmetric, while the distribution of pay per period in education level 17 is skewed left, while the distribution of pay per period in education level 18 is skewed right. Okay, these are some standard charts and graphs that can be used to display the descriptive statistics. Using some specific tools that are designed for data visualization, we can create more interactive views for the data. Now, I'm going to show you how to use a tool called Tableau Public to create these interactive graphs. In Tableau Public, you could create the graphs including the bar chart, also the line chart or the histogram, and all these standard charts. Also, it could create the text table, the heat map, the Gantt bar chart, and the pie chart. So here in this demonstration, we're going to use the employee master data. And then first, I'm going to show you how to create the color encoded nested bar chart. Okay, first let's open this software. So first we can open the data. For the Tableau Public, it can only be used for the data formats in Excel data, the Access file, and the text file. For example, we have stored the employee master data in the Excel file. We just need to import it first. Find the Excel file, choose the first table to import, and to use the first row as the field name, just click OK. And then it could automatically define each columns or each attribute of the table. All the qualitative variables are shown here in the dimensions, and all the quantitative or continuous variables are shown here in the measures. So in order to create a view of the data, you can simply drag the dimensions. For example, here we want to use the job descriptive. You just drag it. You want to show it in columns or in rows, you simply put it here. For example, we want to use the job descriptive in the columns. We just drag it here and put it in the columns. Okay, and if, for example, here we want to use the work department in the rows, also drag it here to put it in the rows. Then the software automatically create a view using the job descriptive as columns and the work department as rows. Then we put the number of records also in the rows to show that there are how many employees in each work department, and they belong to which job description. And in order to create a nested table, you may want to include more variables in this data view. For example, you want to see the location of these employees. You may want to include the country code in the columns. And also here you can use the color to add more information, like the for example, for the sex, if you put it in the color, it will show you the blue indicates the female and the orange indicates male employees. Now here you already created this color encoded nested table, and using the column chart or this bar chart. Okay, so these views include the information from 5 attributes of the table. So usually this kind of interactive charts or graphs can include more information than the traditional charts and graphs. And if you want to remove some attributes from this view, you can just right click it, choose remove. Okay. Now besides this information enriched data view, Tableau Public can also do some calculation of the data very quickly. For example, let's go back to the very beginning of this view when we only have job description and work department. Now here we can create a text table by put the number of record here. Instead of going to the rows, we go to here to the text. Now here it shows the number of the employees in the work department and belongs to each job description. And you can easily calculate the frequency of this distribution by click Analyze. Percentage of, you can just choose the table. It will shows you the relative frequency of this distribution. Then when you just choose totals, you could choose show the row grand total. It will show the total of each rows. And also in the analyze the total, show the column grand total. It will show you the total of each columns. For example, if we want to see the salary of each employee, we just need to add the employee number here in the row, and we go back to the analysis, choose num percentage. It will show the original number. And then since we want to know the salaries, so we put the salaries here in the text instead of the number of records. So it shows the salary of each employees and its work department. Also, we can create a filter here very easily by right click. For example, we want to filter the work department. You can right click it and choose the filter and choose the, maybe if you want to filter out some work department, for example, filter out this one. Also you just want to see the work department D11 and D21. You just click OK, and you will see that there is a filter. In the filter, you can see the work department. It's just to remind you that you have created a filter on the work department. And you could also add color to this text table. For example, you use the country code as the color. Then you will show that here is a legend that tells you each color they're related to which country. So you can see that in the grand total of the columns, there are some color that exist together. So we may just need to not include this in our view. So now you have created a filter and color encoded text table. Another chart that can create it in Tableau Public is called heat map. An example of the heat map can be, use the work department as the columns and remove job descriptive, remove the employee number from the rows, and use the country code in the rows, and remove this filter by choose all of the work department. Now you can see that in text here it shows the sum of the salaries. Now also you could choose the measure here to be to show the average or median or maximum or minimum of the salary. For example, we just show the average of the salary, and then we remove it from the color, and we choose here the marks as the square, and we choose average of salary to indicate as the size, not the label, so we don't have the label in the heat map. And here it shows that the small square indicate the smaller salary, while the larger square indicate the higher salary. Okay, you can also increase the size of the squares by removing the size bar here. So this is a size encoded heat map. You can tell the different average salaries according to the size of each square. Also, you can just assign the squares of the same size, but use color to show the difference. When you move this average salary from size to color, it shows you that the lighter color indicates lower salary, while the darker color indicates the higher salary. Okay, so it's another kind of visualization. Okay, so if you use the size to indicate the difference of the salary, then you may be able to use color to add more information. For example, the job descriptives. If you move job descriptives into color, it will show you each average salary that belongs to which kind of job. Okay. So usually for the color here, if you assign a continuous variable in the color, then it will show you the same color but with lighter or dark color. But if you assign a qualitative variable here in the color, then it will assign different colors for different categories. Then you can add more attributes to this table by using different shapes. For example, when we want to use different shapes to indicate different type of gender, we could first choose the marks from square to the shape here, and then now we assign the sex to the shape, Now you can see that the circle means the female, while the square means the male. For example, for this data record, if you move your mouse onto it, you can see the information of this data records. And you can also tell this information according to the shape, the color, and the large of this mark. Okay, so now in this table, you use different way to present data, but you also include 5 variables in this data view. And another presentation that we cannot do using Excel or the other statistics software is presentation of the geographical data. While here in Tableau Public, you can give your very intuitive way to see the distribution of the geographical information. For example, here, because we have the address and the country, the city, or all this geographical information in this table. So when we input the data, the software automatically creates 2 measures. It's called latitude and longitude to present the geographical information. First, if we just choose the latitude to the column and longitude to the rows, and remove these 2 original columns, and here choose the map. Don't we remove anything else? It will create a map. Then we can move the country code to the level of detail to see that the average salary of each country. Okay, and now because we put average salary here in the size, so the larger circle indicates higher average salary, while the smaller circle indicates the lower salary. Well, also you can see that there are indicators show you that there are 3 unknown values. So when you click into this, you can add it to the location by yourself. Let me show you how to edit this. When you click edit location, it will show that these are the 3 values that are not recognized by the software. So we are going to input the latitude and longitude by ourselves. Okay, for example, let's search for the geographical information of this. Of this 3 country code. Let's see the country. Latitude. Longitude. Okay, here list the latitude and longitude of all the countries according to their country code. First is Australia. We just click it, enter latitude and longitude. Here latitude, what we find is minus 27, and then the longitude is 133. We'll click OK. It will enter into the software, and then for the next one, we search, find it, and enter it. Then for the last one, okay, click OK. You can see that several more points are added, like in Australia, and several in Europe, like Sweden here. Okay, now here, in this map, it could give you a more intuitive way to understand the average salary that distributed in the worldwide. Okay, and another view for this geographical map, when you click here to form a field map, it's just use the color to indicate the average salaries. Okay, in order to add more information to this geographical chart, you could choose the automatic mark to the pie, and then it allows you to add more attributes here. For example, to the color, you can add job descriptive to demonstrate the different distribution of different jobs in each country. Okay, so these are the basically types of data visualizations that Tableau Public can show, and it also definitely has some more functions. Then you could explore this by click the help topic. You could give your detailed instruction of how to use this software. Because of the time limitation, I'm not going to show you each of these functions in Tableau Public. Some of them are related to the calculation, or some of them just tell you how to use this to create the standard charts. It's also very easy and convenient to use this software to create the basic charts that we have discussed. But you can find this comprehensive instruction here online. So you could, if you have time, you could explore this software by yourself.
Okay, I want to make some extensions to Chi's lecture. First, she didn't upgrade her Tableau Public, so the version she was using is not the same one as we downloaded recently. However, all the functions she was using can be easily replicated using the version we have. So I encourage you to play with this software. Second, if you notice on the left side, Tableau Public automatically recognizes dimensions and measures when you imported the dataset. Dimensions are like categorical variables, while measures are like numerical variables. However, this may not accurately reflect how we want to use these variables. For example, if you notice here, educational level is recognized as a measure. For our own purpose, we may want to see the average salary of people with different education level. Let's try if we simply put educational level to the column and the salary to the row. We convert some salary to average. As you can see, we cannot get the figure that we are interested in. Well, this is because that in the column, educational level is also considered as numeric, and this is not what we want. There are two ways that we can adjust this. The first one is to also keep educational level in the column, but convert it to dimension. Right-click it and choose dimension. And you can see now that we get a line figure. Another way we can do this is to move educational level from measure to dimensions here. As you can see, if we drag it to dimensions, it is considered as dimensions now. And now let's put salary in row and educational level in column. We can see a bar chart, and this is because the educational level is dragged to dimensions and it is considered as categorical variable. You can put any variable into dimensions or measures. Sometimes, in some extreme cases, you may want to use one variable as both dimension and measure. In this case, you can choose to duplicate it and drag the duplicated one to measures. And now you have educational level in both dimension and measure. For this figure, we can change it to a line chart. And if you can notice, when you're comparing these two figures, for this one, there is empty value for 13. There is empty value for 13, while for this one, there is no empty value for 13. Well, this relates to how we adjust this variable. If we adjust it in the column to dimensions, then although it is considered as a categorical variable, but it is still considered as ordinal. So there is order inside it, and from 12 to 14, it will recognize that there is one more number between it, although there is no one has this educational level. So it will put a value of 0 here. But for this one, if we drag the educational level to dimensions, so now educational level is simply considered as nominal. So we need to notice this difference here. Suppose now that you want to export this figure into other, like in your presentations. This is problematic. If you right-click it, you cannot see any option to copy this figure. This is because Tableau Public is designed for sharing, not for generating report. But this is not a problem for Tableau Desktop. Tableau Desktop is a paid software tool. You have two options to obtain it. The first one is to try the free trial. Free trial can work for 2 weeks. Another way to get Tableau Desktop, which I recommend, is to use the educational version. It can give you free access to Tableau Desktop for 1 year. If you go to this website, Tableau Academic Program, and drag down, you can see free student edition. Click it, and you need to fill in this form. Remember, use your Rogers email here so that it can recognize that you are indeed a student, and then click submit. After this, you will receive an email from Tableau soon after you submitted it, and you have the download link and the product keys inside that email. I have already downloaded it, so let me simply show you how it works. First, it can import more types of data. Now we also import employee master. And we do the same thing. We put educational level in the column. We put salary in the row. Choose average salary. Choose line chart. And now we may want to add an additional one, such as country, using different colors. And you can see this. Now if you want to export this figure, you can right click it, copy image. From here you can choose different format to export it. We can choose the simplest one, copy it, and if you can see, the figure is like this, and the legend is generated automatically. If you don't use Tableau Desktop and you just use Tableau Public, then you cannot generate this legend. What you can do is either to copy this figure without any explanation on different colors, or copy the whole figure and you will have something unnecessary in your figure. And one more feature of Tableau Desktop is that you can save your work in local locations. You can choose to save as and choose it as local. But for Tableau Public, you can only save it to the web. You have to first create an account on Tableau Public and then save it to the web. If you don't have internet access, then it means you cannot save your work. This is problematic. So to sum up, Tableau Desktop is more flexible. You can use your Rogers email to download it for 1 year period. Okay, I think that's all for this week's lecture, and hope you can enjoy the rest of the week.